In this session, we'll discuss about the electric potential and capacitance chapter. In that, 3 marks questions and expected 3 marks questions and 5 marks questions. Okay. ತುಂಬಾನೇ ಕಡಿಮೆ ಇದೆ ಇದು ಜಾಸ್ತಿ ಏನಿಲ್ಲ. ಸೊ 3 marks ಮತ್ತೆ 5 marks ನ ಹೇಗೆ ಯಾವ ಟೈಪ್ ಇಂದ ಬರ್ಬೋದು ಅಂತ ನೋಡ್ಬಿಟ್ಟು ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗೋಣ ಅಂತೆ. ಓಕೆ. First question ನೋಡಿ, derive the expression for potential due to a system of charges. Okay. ಒಂದೊಂದಾಗಿ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಡಿರೈವ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕಾಗತ್ತೆ ನಾವು ಇದರಲ್ಲಿ. First, derive the expression for potential due to a system of charges. Okay, system of charges ಗೆ potential ಏನಿದೆ ಅಂತ ನೋಡ್ತಾ ಹೋಗೋಣ. So potential to, so what we had to consider a system of charges here. So first point charges ಗೆ easy ಇರುತ್ತೆ, or system of charges ಕೇಳಿದರೆ ಹಾಗಾಗಿ ಏನು ಮಾಡಬೇಕು ಇವಾಗ. So first question, so you have to draw like this. Okay, system of charges. ಈ ತರ ಬರೆಯೋಣ ಅಂತೆ. ಸೊ ಇದೇನಿದೆ, ಫ್ರಮ್ ದ ಪಾಯಿಂಟ್ ಆಫ್ ಫ್ರಮ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಪಿ ಸಿಸ್ಟಮ್ ಆಫ್ ಚಾರ್ಜಸ್ ಆರ್ Q1 Q2 Q3 ಅಂತ ಬರೆಯೋಣ. ಸೊ ನೆಕ್ಸ್ಟ್ these charges are separated by a distance. Okay, so P of R1 ಅಂತ ಬರೆಯೋಣ, R2 R3 R4 ಅಂತ ಇತರ ಡಿಸ್ಟೆನ್ಸಸ್ ಅಲ್ಲಿ ಇರುತ್ತೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಇವಾಗ ಹೆಂಗ್ ಮಾಡೋದು? ಸೊ ವಿ ನೋ ದಟ್. ಓಕೆ, ಕನ್ಸಿಡರ್ ಎ ಸಿಸ್ಟಮ್ ಆಫ್ ಚಾರ್ಜಸ್ Q1 Q2. ಸೊ ಬೇಕಾದಷ್ಟು ಚಾರ್ಜಸ್ ಇರುತ್ತೆ ವಿತ್ ವೆಕ್ಟರ್ಸ್ R1 R2 ಎಲ್ಲ ವೆಕ್ಟರ್ಸ್ ಇರುತ್ತೆ. ಎಂದು ದಟ್ ಈಸ್ ಅ position vectors. R1 R2 are not position vectors. So it's just add ಮಾಡಕ್ಕಾಗಲ್ಲ ಯಾಕಂದ್ರೆ it is a vector. Okay, add ಮಾಡೋದಿದ್ರೆ ಅವಾಗ ಏನ್ ಮಾಡೋಣ, potential V1 at point due to charge. So due to charge consider point P with system of charges Q1 Q2 etc. Okay, and separated by distance. What is the distance here? R1 R2 etc. So these are all various vectors. Okay, due to charge Q1. Okay, separate calculate ಮಾಡೋಣ. Potential V1 at P is, okay, V1 is equal to 1 by 4 pi epsilon naught into Q1 by R1. Okay, same thing it continues. Okay, V2 is the Q1 ಮತ್ತೆ R1 ಗೆ difference ಇದೆಯೋ that is the distance. Okay, same thing is similarly for V2 is equal to 1 divided by 4 pi epsilon naught into Q2 by R. This will continue. Now, what is this? There is an algebraic sum. We have to add that's it. Okay, V1 plus V2 plus V3 like this. It continues. That is 1 by 4 pi epsilon naught constant of the time. But already expressions na bardidivi. Okay. So this is known as by the superposition theorem. By superposition theorem, you can add these things. Okay, V3 etc. 1 by 4 pi epsilon naught into like this. You can add so that what happens 1 by 4 pi epsilon naught into. So you know, to Q1 by R1 plus Q2 by R. Already I wrote the expression. Okay, for 1 mark question or 2 marks question. So 1 by Q1 R1 by Q2 R2 divided by like this. It continues. Okay, like this system of charges. So potentially, I would say the potential is given by Q. So this whole R, okay, the whole charges we can summarize as a Q, and R is what? Small r can be written as capital R. So that is a of its surface. Okay, this implies that there's a system of charges. That is this is the potential due to for the system of charges we can calculate. Okay. Question for next one is electric field and electric potential. Electric field and electric potential. Expression for electric field with electric potential ಗೆ expression derive ಮಾಡಬೇಕು ನಾವು ಇವಾಗ ಹೇಗೆ ಮಾಡೋದು ಎಲ್ಲದೂ ಸಹ 3 marks questions ಅಲ್ಲಿ ಈ ತರನೇ ಕೇಳಿರ್ತಾರೆ ಓಕೆ what is known by what is the so now we will derive this one now electric field expression for electric field and electric potential is equal to minus delta into V. Consider a positive point charge Q at the origin. Consider point charge Q at the origin. Calculate the electric potential at a point P at a distance R from this one charge. Definition of potential as work done. Okay, this means that P is equal to what? So if you want to calculate the potential, simple agi ಮಾಡೋಣ ಇವಾಗ potential defined as ಏನಂತ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ work done, correct or not? Work done in moving a test charge from point infinity to that point P. That is equation V is equal to K into Q by R. This is the equation, correct or not? This is the equation for a potential. Consider a point charge Q. Potential is defined as what? Work done in moving a point charge from that point to that, correct? That is the formula. Okay, next one is what is electric field here? Electric field at a point is defined as the force experienced by a unit positive test charge. Okay, force experienced. Electric field is the force experienced, correct or not? That is AF by Q. Okay, that is E is equal to what? Actually, E is equal to K into, correct or not? F by Q means Q divided by R square. Now relate the relation. So ಎರಡು relation ಮಾಡಿದ್ರೆ E is equal to Q into Q by R square. This is, so now it has given an expression for electric field and electric potential. So E is equal to what? You can write like this. Difference ಏನಿದೆ ಇವಾಗ E is equal to, so ಏನಿದೆ ವ್ಯತ್ಯಾಸ? Correct. So d by dv by dx, correct? Not so the differentiation of this one, correct? So we have the differentiation of this one. Differentiation. Okay, we have to take the differentiation for electric field also and this one for this also potential also. And write like this: E is equal to minus dv by dx. dx ಅಂತ ಬರೆಯೋದು, dv ಅಂತ ಬರೆಯೋದು. ಇದೆರಡು ಕಂಪ್ಯಾರಿಸನ್ like this equals the potential difference VA minus VP. It is like this. So E is equal to, this is the answer. You can write this. Okay. So ಇದರ expressions ನ ಎರಡಕ್ಕೂ ಸಹ ಡಿರೈವ್ ಮಾಡಿ ಬರೀಬಹುದು. So this K Q by R square ಇದಕ್ಕೆ ಏನಾಗುತ್ತೆ? differentiation ತಗೊಂಡ್ರೆ ಇದಕ್ಕೆ you will get the energy. So that is, we can write like this. Okay, dv by R. This is the how we have to derive the expression for the electric field and electric potential. So exact textbook ಅಲ್ಲಿ ಇದನ್ನೇ ಕೊಟ್ಟಿದ್ದಾರೆ, correct? ಹೇಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತ ಹೇಳ್ತೀನಿ ನೋಡಿ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ. ಸೊ ಈ ತರ ಒಂದು ಎರಡು ಡಿಫರೆಂಟ್ ಪೊಟೆನ್ಶಿಯಲ್ ಡಿವಿಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಕರೆಕ್ಟ್ ಆರ್ ನಾಟ್? ಸೊ ಇದ್ರಲ್ಲಿ ಏನು ಮಾಡಬೇಕು? ವಿ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್, ಓಕೆ, ಬಿಟ್ವೀನ್ ವಿ ಎ ಅಂಡ್ ಬಿ ಬಿ. ದಿಸ್ ಪಾಯಿಂಟ್ is where is the point is here, the point P. That is, okay, so here the point P. Next one is, this is having a potential difference of V and here it is V. So that what is this? E into dl. Okay, d of L. That is a small L. V minus V plus delta V. What is this? Difference between these two potential differences. A is V. VA minus VB and the potential difference. Then dV is equal to negative of this one. So E is equal to what? E is equal to, very simple. P of D into dl. P of what? Of the unit length of this area ಇದೆ. ಇದು ಏನು area length, ಏನು length of a conductor is given like this. If you do like this, get the answer ಈ ತರ ಮಾಡ್ಬಿಟ್ರೆ ಸಾಕು, ಈಸಿಯಾಗಿ ಸಿಗುತ್ತೆ ನಿಮಗೆ. ಓಕೆ, ಇದೆಲ್ಲ 5 marks ಇಂದು, 3 marks ಇಂದು. What is the expression for the capacitance of a parallel plate capacitor? ಸೊ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಎರಡು ಪ್ಯಾರಲ್ ಪ್ಲೇಟ್ ಇರುತ್ತೆ, ಅದಕ್ಕೆ ಡಿಸ್ಟೆನ್ಸ್ ಡಿ ಇದೆ, ಕರೆಕ್ಟ್ ನಾಟ್? ಸೊ ಏರಿಯಾ ಆಫ್ ಪ್ಯಾರಲ್ ಪ್ಲೇಟ್ ಇಸ್ ಎ. ಓಕೆ, ಸೊ ಅದನ್ನ ನೋಡೋಣ. How to solve this one? Parallel plate capacitor. Capacitance of a parallel plate capacitor. So it has a that is parallel plates like this. Idra itkoli atva textbook alli idange utana baribodu. Illi ಒಂದು parallel plate ಅಂದ್ರೆ ಏನು? It will stores the charges, right? It is made up of a one parallel plate of area of cross section A. Distance is how much? D. Okay. ಇದು ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಇದ್ರೆ ಇದು ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಇರುತ್ತೆ, ಹೌದಾ? ಆಪೋಸಿಟ್ ಚಾರ್ಜಸ್ ಅಕ್ಯುಮುಲೇಟ್ ಆಗಿರುತ್ತೆ ಇಲ್ಲಿ. ಓಕೆ, and it is having a charge density of sigma. ಇದೆಲ್ಲ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕು. ಔಟರ್ ರೀಜನ್ I, region above the plate 1. So E is equal to what? So it is region 1. This is the first plate and this is a second plate. Okay, what we have to calculate is now sigma. So E is equal to the amount of charges sigma divided by 2 into epsilon naught irutte. Okay, so that is surface charges will be like this. Okay, sigma divided by epsilon naught, sigma plus epsilon naught, that is plus sigma by 2 epsilon naught. What is this? This is for first capacitor and the second capacitor. ಎರಡೂ ಸಹ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎರಡು ಸೇರಿಸ್ತಾನೆ ಆಗ್ಬೇಕು. ಸಿಗ್ಮಾ ಅವಾಗ ಏನಾಯ್ತು? ಸಿಗ್ಮಾ ಬೈ ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಆಯ್ತು. That is equal to what? From the in accordance with what? In accordance with the sigma by epsilon naught can be written as Q divided by epsilon naught into A. This is the formula. Correct? So, but we know that V is equal to what? V is equal to E into D. We know that potential difference across this one is nothing but V into D. That is equal to 1 by epsilon naught into Q into D by A. That's the formula. That is V, but we know that C is equal to Q by V. Q is nothing but charge, correct? Not charge. Charge get cancels here. That is, see what we want. We want capacitance of a capacitor between the plates. Okay, first to electric field ಅಂತ ತಗೊಂಡ್ವಿ. ಅದರಿಂದ ಏನ್ ಮಾಡಿದ್ವಿ ನಾವು? ನೆಕ್ಸ್ಟ್ ವೋಲ್ಟೇಜ್ ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸ್ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕು ನಾವು ಇದರಲ್ಲಿ. ಓಕೆ, so E into D, that is equal to 1 by epsilon naught into Q into D divided by A. Formula apply ಮಾಡೋಣ. That is next to capacitance of a capacitor is given by, we know ಮತ್ತೆ we know that. Okay, capacitance of a capacitor is given by C is equal to Q by V. It's very important. And C is equal to what? Q is what here? Q, and V is how much? 1 by epsilon naught. ಅವಾಗ ಏನಾಗುತ್ತೆ? epsilon naught ಹೊರಗಡೆ ಬರುತ್ತೆ, Q get cancel ಆಗುತ್ತೆ, correct? not A ಬರುತ್ತೆ, D, correct? C is equal to epsilon naught into A divided by V, D, that we arrived. So ಇದನ್ನ ಯೂಸ್ ಮಾಡ್ಬಿಟ್ಟು ಸಾಲ್ವ್ ಮಾಡಿದ್ವಿ ಪ್ರಾಬ್ಲಮ್ಸ್ ಎಲ್ಲ. ಬಟ್ ನಾವು ಮಾಡ್ಬೇಕಾಗಿರೋದು ಇವಾಗ, we have to calculate the capacitance. We have to arrive an expression for the capacitance of a capacitor. Capacitance of a capacitor, okay, of a parallel plate. Okay, for this we have to take the energy distribution, the electric field distribution with the charge distribution. So sigma divided by 2 epsilon naught. This is a formula. If you add like this, you will get sigma by epsilon naught. Okay, and this E is equal to sigma by epsilon naught, but V is equal to what? E is equal to Q into epsilon naught by A. Because of what? This is a charge density is given by charge divided by area. Sigma is what? Sigma is the correct A, that is area, charge density. Last first ಮಾಡಿ surface density, charge density, area density ಇರುತ್ತೆ, ಅದಕ್ಕೋಸ್ಕರ Q by A ಬರೀತೀವಿ ನಾವು. ಸೊ ಅದೆಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಈಸಿ ಆಗಿ ನಮಗೆ derivations ಸಿಕ್ಬಿಡುತ್ತೆ. Okay, next one is parallel plate capacitor derivation ಆಯ್ತು. Effective capacitance of a series combination of two capacitors. So two capacitors ಇದ್ದಾಗ ಏನ್ ಮಾಡ್ಬೇಕು? C by V, correct? Series combination ಅಂದ್ರೆ ಹೆಂಗಿರುತ್ತೆ? So one is like this and the other is like this, correct? ಎರಡು ಮೂರು ಎಷ್ಟು ಪಕ್ಕ ತಗೊಳ್ಳೋಣ ನಾವು ಇವಾಗ. ಸೊ ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಇರುತ್ತೆ, ಪಾಸಿಟಿವ್ Q, ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಇರುತ್ತೆ. ಸೇಮ್ ಥಿಂಗ್ ಆಸ್ ಎಂಡ್ ಟು ಎಂಡ್ ಕನೆಕ್ಷನ್ ಅಂತ ಹೇಳ್ತೀವಲ್ಲ, ಅದನ್ನ ಸೀರೀಸ್ ಕನೆಕ್ಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಲೈಕ್ ದಿಸ್ ಯು ವಿಲ್ ಟೇಕ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ಒನ್ C1 capacitor and this is one C2 capacitor. ಇಲ್ಲಿ ಪ್ಲಸ್ ಎಲ್ಲದ ಕಡೆದು ಇಲ್ಲಿ ಮೈನಸ್ ಇರುತ್ತೆ. If you connect, that is in a series combination, then what happens? Capacitor, since this is a ಎರಡನೇ ತಗೊಂಡಿದ್ದೀನಿ ನಾನು, ಅವಾಗ ಏನಾಯ್ತು, ಸೊ ಪೊಟೆನ್ಶಿಯಲ್ ಡಿಫರೆನ್ಸಸ್ ಆಡ್ಸ್ ಅಪ್. ಓಕೆ, V is equal to V1 plus V2, that is equal to what? Q by C1 plus Q by C2. What we have to calculate now here? It is potential differences, but we know that what? We know that C is equal to Q by V. 1 by C is equal to, so 1 by C1 plus V by Q is equal to 1 by C1 plus 1 by C2. So what one is common here? V is equal to V1 plus V2, or V by Q is equal to 1 by C. But we know that V by Q is what? V by Q is equal to 1 by C. That is equal to what? 1 by C of S, because it is in series, right? 1 by C1 plus 1 by C2. This is the capacitance in parallel. Series is simple. Okay. Yes, so 2 capacitors. Number of capacitors increases means what? 1 by C of S is equal to 1 by C1 plus 1 by C2. It continues up to 1 by C of N. Number of capacitors. How many number of capacitors are there? No, like that we will arrange. Okay. That parallel Q is equal to Q1 is C1 into V, Q2 into C2 into V. So parallel parallel just add agatte. Okay, here it is. Parallel, if it is like this, ಇದೇ ತರ ಎರಡನ್ನ ಮಾತ್ರ ತಗೊಂಡಿದ್ದೀನಿ ನಾನು ಕಾಂಬಿನೇಷನ್ಸ್, ಅದೇ ತರ ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಇದು ಎರಡು ಟರ್ಮಿನಲ್ಸ್ ಇಸ್ ಲೈಕ್ ದಿಸ್. ಓಕೆ, ಇಫ್ ಇಟ್ ಇಸ್ ಲೈಕ್ ದಿಸ್, ದೆನ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್? ದಟ್ ಈಸ್ Q1 is equal to C1 into V. ಯಾಕಂದ್ರೆ ವೋಲ್ಟೇಜ್ ಏನು ಚೇಂಜ್ ಆಗಲ್ಲ. ಓಕೆ, ಇನ್ ದ ಪ್ಯಾರಲ್ ಕಾಂಬಿನೇಷನ್. Okay, Q2 is equal to C2 into V. Correct? Q is what? Q is equal to Q1 plus Q2. That is superposition of charges. Superposition of theorems. That is equal to what? Q is equal to C1 V1 plus C2 V2. C1 V1 C1 V plus C2 V. Okay, C is equal to C1 plus C2. Q is what? Q is equal to, C is constant, right? C is equal to C1 plus C2. Correct? Because Q is what? V is here constant. Q is equal to, V is here constant, C1 plus C2. That is what Q is equal to Q by V. Q by V. Q by V is nothing but what? C. Correct? Step by step barita hogi ನೀವು. Okay, so Q is equal to V into C1 plus C2. So first Q1 is equal to C1 plus V, Q2 is equal to C2 plus V. If you add Q is equal to C1, this one, V is constant, C1 plus C2 is remaining, Q by V is nothing but, Q by V is nothing but C, that is equal to C1 plus C2. This continue ಆಗ್ತಾ ಹೋಗುತ್ತೆ. C of parallel is equal to C1 plus C2 plus how much? C of N. That is a parallel combination ಆಯ್ತು, series combination ಆಯ್ತು. Expressions again. Okay. There are expression for the energy stored in a capacitor. Energy stored in a capacitor. Formula I know. Energy stored in a capacitor. Derivation ಮಾಡಬೇಕು ನಾವಾಗ. ಸುಮಾರು ಡೆರಿವೇಶನ್ಸ್ ಇದೆ ಇದರಲ್ಲಿ. ಸೊ ಈ ಕ್ವೆಶ್ಚನ್ಸ್ ಇದರಿಂದ ಎಷ್ಟು ಬರುತ್ತೆ? 11 ಮಾರ್ಕ್ಸ್ ಬರುತ್ತೆ. ಸೊ ದಟ್ ವಿ ಶುಡ್ ಬಿ ವೆರಿ ಕೇರ್ಫುಲ್. If you take the capacitor like this, okay, capacitor, how much energy will be stored? That we have to find out. So it is a parallel plate capacitor. Okay, positive irutte, negative irutte, Q plus irutte. One plate is made up of charges. It is negative. Okay, next one is the electric field is what it is. There exists the electric field like this. Okay, how much the work done in bringing a charge? Okay, there's energy, energy in bringing a charge from position here to here. Okay, that we have to calculate. There exists here it is, okay. If work done, W is the work done in moving a charge from first conductor, this is the first one. The first two is given by W is equal to, okay, 0 to Q of Q by C into delta Q. Okay, this is the integration. So ಇದೆಲ್ಲದಕ್ಕೂ ಸೇರಿಸಿ ತಗೊಬೇಕಾದ್ರೆ ಇಂಟಿಗ್ರೇಷನ್ ತಗೊಂಡ್ರೆ ಸಾಕು. ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಬಿಡಿ ನೀವು, ಏನೂ ಆಗಲ್ಲ. ಸೊ ಕ್ಯೂ ಪ್ಲಸ್ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಇಲ್ಲಿಂದ ಕ್ಯೂ ಇಂದ ಕ್ಯೂ ಪ್ಲಸ್ ಡೆಲ್ಟಾ ಕ್ಯೂ ಅಷ್ಟು ಚೇಂಜ್ ಆಗಿದೆ. ಇಲ್ಲಿ ಚಾರ್ಜ್ ಇಲ್ಲಿ ಕ್ಯೂ ಇದ್ರೆ ಇಲ್ಲಿ ಕ್ಯೂ ಪ್ಲಸ್ ಡೆಲ್ಟಾ ಕ್ಯೂ ಅಷ್ಟು ಚೇಂಜ್ ಆಗುತ್ತೆ. ಅವಾಗ ಏನಾಯ್ತು, how much it is changed, we can calculate the work done in bringing this one. Okay, that means is equal to what if you do like this. Okay, Q integration of Q is nothing but Q2 by 2 Q square by Q square, and what is this, 1 by C is what, 1 by C is the constant. Okay, Q square by 2 from 0 to Q, correct. So it is the answer. And W is equal to half CV square. W is equal to easily multiply half CV square. Why? Because Q is nothing but what? Q is nothing but W is equal to half of Q square divided by 2C. Correct? Q square divided by C. But Q is what? Q is equal to C into Q is equal to C into V. Correct or not? Q is equal to C into V. So that wherever Q is there, no, you have to substitute for Q into V into square. Here it is W is equal to half of CV whole square divided by V. So that it cancels C dividing it. So energy stored in the capacitor of the work done is nothing but energy is equal to, this is the answer. Energy is nothing but work done of energy is equal to half. Energy stored in the capacitor is given by half into C. ಮಾಡಾಗಿದೆ ನೀವು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರ್ದಿತ್ತು, ಬಟ್ ರಿಲೇಷನ್ಸ್ ಮಾಡಿಲ್ಲ. ಸೊ 3 ಮಾರ್ಕ್ಸ್ ಗೆ ಇಷ್ಟಿಷ್ಟನ್ನ ಬರ್ದ್ರೆ ಸಾಕು ನೀವು. ಓಕೆ, 3 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸ್ ಇದು. 5 ಮಾರ್ಕ್ಸ್ ಎನರ್ಜಿ ಡೆನ್ಸಿಟಿನೂ ಕೇಳ್ತಾರೆ ಜೊತೆಗೆ, ಅದನ್ನ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. ಸೊ ಇದು 5 ಮಾರ್ಕ್ಸ್ ಆದ್ರೆ ಎನರ್ಜಿ ಡೆನ್ಸಿಟಿ, ಸೊ ಇಟ್ ಇಸ್ E is equal to energy density, E is equal to sigma by epsilon naught. Correct or not? That is that we have to apply here. Energy density here. Next is what U is equal to half of epsilon naught into E square, that into A into D. Why? Because A is the formula. Energy stored in the capacitor is given by U is equal to ಇದನ್ನ ಅಪ್ಲೈ ಮಾಡೋದಾಯ್ತು. ಓಕೆ, ವೈ? ಬಿಕಾಸ್ ಕೆಪಾಸಿಟೆನ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ, ಕೆಪಾಸಿಟೆನ್ಸ್ ಫಾರ್ಮುಲಾ ಹಾಕೋದಾಯ್ತು ಇಲ್ಲಿ. ಸೊ ದಟ್ ಈಸ್ ಯು ಇಸ್ ಈಕ್ವಲ್ ಟು ಹೌ ಮಚ್, ಎನರ್ಜಿ ಡೆನ್ಸಿಟಿ ಪರ್ ಯೂನಿಟ್ ವಾಲ್ಯೂಮ್. Space is given by U is equal to half of epsilon naught into E square. A into D is what? Volume. So area into distance gives the volume, but per unit volume ಇರೋದ್ರಿಂದ, so we can write like this. Okay, ಅದೆರಡು 1 ಆಗುತ್ತೆ. A into D is volume is equal to 1 ಆಗುತ್ತೆ. That is equal to, so energy density is given by half into epsilon naught into E square. ಈ ಫಾರ್ಮುಲಾ ಸಹ ಅರೇಂಜ್ ಮಾಡ್ಬೋದು 5 ಮಾರ್ಕ್ಸ್. ಇದು 5 ಮಾರ್ಕ್ಸ್ ಗೆ ಕೊಟ್ಟಿದಾರಲ್ಲ, 5 ಮಾರ್ಕ್ಸ್ ಗೆ ಹಂಗಾಗಿ ಮಾಡಿರೋದು. ಸೊ 3 ಮಾರ್ಕ್ಸ್ 5 ಮಾರ್ಕ್ಸ್ ಏನಿರುತ್ತೆ, ಎಕ್ಸ್ಟೆನ್ಷನ್ ಇರುತ್ತೆ ಅಷ್ಟೇ. 3 ಮಾರ್ಕ್ಸ್ ಡೆರಿವೇಷನ್ಸ್ ಏನಿರುತ್ತೆ ಅದನ್ನ ಎಕ್ಸ್ಟ್ರಾ ಡೆರಿವ್ ಮಾಡಬೇಕು 5 ಮಾರ್ಕ್ಸ್ ಗೆ. ಸೊ ದಿಸ್ ಆರ್ ಆಲ್ ದ ಥಿಂಗ್ಸ್. ಎರಡನ್ನೂ ಸಹ ಮಾಡ್ತಾ ಹೋಗ್ತಾ ಇದೀನಿ ನನ್ನ ಜೊತೆಗೆ, ನೋಡ್ತಾ ಹೋಗಿ. Describe the construction working of a Van de Graaff generator with schematic diagram. So Van de Graaff generator ಮಾಡೋಣ. 5 marks question ಇದು. Okay, 3 marks ಗೂ ಸಹ ಕೇಳಬಹುದು. Van de Graaff generator. Van de Graaff generator. ಕನ್ಸ್ಟ್ರಕ್ಷನ್ ಬರೀಬೇಕು, ವರ್ಕಿಂಗ್ ಬರೀಬೇಕು, ಎಲ್ಲದನ್ನು ಸಹ ಮಾಡ್ತಾ ಹೋಗೋಣ. ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಲಾಸ್ಟ್ ಸೆಷನ್ ಹೇಳ್ದಂಗೆ ಏನಿದೆ ಅಂತಂದ್ರೆ ವ್ಯಾಂಡಿಂಗ್ ಆಫ್ ಜನರೇಟರ್ ಇಸ್ ಅನ್ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ ವಿಚ್ ಇಸ್ ಯೂಸ್ ಟು accelerate the charges. Correct or not? So what are the concepts behind in the winding of generator that you have to study? Correct? ಹೆಂಗಿರುತ್ತಪ್ಪ winding of generator ಅಂದ್ರೆ it looks like this. It is a one itara conductor irutte. Okay, large hollow spherical conductor is fixed on the insulating stand. One insulating stand mele right. Okay, insulating stand. Stand, spherical conductor. ಸೆಂಟ್ರಲ್ ಇರುತ್ತೆ, ಪುಲ್ಲಿ ಇರುತ್ತೆ. ಕರೆಕ್ಟ್. ಪುಲ್ಲಿ ಅಂತಂದ್ರೇನು? ಮೂವ್ ಆಗ್ಬೇಕಲ್ವಾ ಅದು. ಸೊ ಪುಲ್ಲಿ ಇರುತ್ತೆ ಸೆಂಟ್ರಲ್ಲಿ. ಓಕೆ, so over which what rubber belt is moving. Pulley is there. Next insulating stand ಇದೆ. Insulating stand ಇದು. ಇದರಿಂದ ಏನಾಗಿರುತ್ತೆ, ಚಾರ್ಜಸ್ ಎಲ್ಲ ಇಲ್ಲಿಂದ ಬಂದಿರುವಂತ ಚಾರ್ಜಸ್ ಎಲ್ಲ ಅರ್ಥಿಂಗ್ ಆಗಿರುತ್ತೆ. ಸೊ ಇಟ್ ಇಸ್ ಕನೆಕ್ಟೆಡ್ ಟು ಇದು ಸ್ಕಿಮ್ಯಾಟಿಕ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್. ಈ ತರ ಎಲ್ಲ ಇದು ಆಕ್ಚುಲಿ. ಸೊ ಸ್ಕಿಮ್ಯಾಟಿಕ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಈ ತರ ಇರುತ್ತೆ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ವಾಟ್ ಇಸ್ ದಿಸ್, ಹೌ ಇಟ್ ವರ್ಕ್ಸ್ ಅಂಡ್ ಎಲ್ಲಾನು ಬರ್ತಾ ಹೋಗೋಣ ಏನಿದೆ ಅಂತ. Construction. So it is a schematic representation. Next is construction. So construction is how it is made up of, what it is made up of. It is made up of electrostatic induction and action at points. Electrostatic induction and action at points is the winding of generator in the principle. Electrostatic induction is the principle behind the electrostatic induction, the principle behind the winding of generator. ಅದನ್ನ 1 mark question ಕೇಳಿದ್ರು, ನಾನು ಹೇಳಿಲ್ಲ. ಯಾಕೆಂದ್ರೆ ಇಲ್ಲಿ ಆಲ್ರೆಡಿ ಇವಾಗ 5 marks ಅಲ್ಲಿ ಹೇಳ್ಬೇಕಲ್ವಾ. electrostatic induction is the principle. Okay, principle in the construction of this one. Okay, next one is construction is a large hollow spherical conductor is fixed on the insulating stand. Pulley B is mounted at the center of the hollow sphere and another pulley C is fixed at bottom. ಏನಕ್ಕೆ? ರಬ್ಬರ್ ಬೆಲ್ಟ್ ಓಡಾಡ್ಬೇಕು ಅದ್ರ ಮೇಲೆ. ಓಕೆ, a belt made up of rubber runs over both the pulleys. By the action of electric motor, okay, Pulley C is driven continuously. ಮೂವ್ ಆಗ್ತಾನೆ ಇರುತ್ತೆ pulley C. ಓಕೆ, ಅದೆರಡು ಕಂಟಿನ್ಯೂಷನ್ ಏನಿದೆ? Two metallic conductors E and D. ಎಲ್ಲಿದೆ? ಮೆಟಾಲಿಕ್ ಕಂಡಕ್ಟರ್ಸ್ E and D ಇದೆಲ್ಲ, ಅದನ್ನ ಬರಿಬೇಕು ನಾವು ಇವಾಗ. ಮೆಟಾಲಿಕ್ ಕಂಡಕ್ಟರ್ಸ್ E and D. ಇಲ್ಲಿ ಒಂದಿದೆ, ಇದಿದೆಲ್ಲ, ಇದೊಂದು E, ಇದು D ನ, ಇದು D. And the other one is that here comb shape. Okay, comb shape ಇರುತ್ತೆ ಇದರಲ್ಲಿ. E ಇರುತ್ತೆ, ಎರಡು ಬೇಕು ಏಕೆ? ಕಂಡಕ್ಷನ್ಸ್ ಗೆ. ಓಕೆ, E and D are fixed near pulleys. Next is what working, how it works. Due to high electric field, because it is maintained at 104 volts. So ತುಂಬಾ ಜಾಸ್ತಿ ಇರುತ್ತೆ electric field near D. Okay, air between belt and ಏರ್ ಏನಾಗುತ್ತೆ? ಅಯನೈಸ್ ಆಗ್ಬಿಡುತ್ತೆ. ಅಯನೈಸ್ ಅಂದ್ರೇನು? ಸೊ ಆಟಮ್ ಇರೋದೆಲ್ಲ ಏನಾಗ್ಬಿಡುತ್ತೆ? ಅಯಾನ್ಸ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ಬಿಡುತ್ತೆ. ಓಕೆ, ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಗಿ ಹೊರಗಡೆ ಬಂದ್ಬಿಡುತ್ತೆ, ಇದು ಅಯಾನ್ಸ್ ಆಗುತ್ತೆ, ಅಯನೈಸ್ಡ್. ಓಕೆ, ಬೆಲ್ಟ್ ಅಂಡ್ ಕೂಮ್ D gets ionized. Positive charges are pushed towards belt and negative charges are attracted to D. Positive charges move upward through belt. Correct? Not from belt, it will move upward. Belt join ಅದೇನಾಯ್ತು? ಮೇಲ್ಗಡೆ ಹೋಗುತ್ತೆ. Large amount ಈ ಹತ್ರ ಹೋಯ್ತು. ಓಕೆ, ಈ ಹತ್ರ ಹೋದ ತಕ್ಷಣ ಏನಾಯ್ತು? Large amount of positive charges are induced. Very, very important. Okay, it is based on what? It is based on the induction only. Okay, induced. Induced ಅಂದ್ರೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಅಲ್ಲಿ ಹೋದ್ರೆ ಏನಾಯ್ತು? ಇಂಡ್ಯೂಸ್ ಆಗುತ್ತೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ on either side of whom E due to electrostatic induction. This is the principle behind the Van de Graaff generator. Electrostatic induction. Due to this, positive charges are pushed and reach outer surface of sphere. Since sphere is a conductor, positive charges uniformly distributed. Very, very important. So this is a induction, right? How to do induction? For uniformly distributed on the outer surface. negative charges nullify positive charges. Belt goes up and down, up and what is that? Positive charges increases at top. This process increases and potential difference outer surface develops, produces potential difference of 10 to the power of 7. Okay. Cannot, this is a maximum limit. This much of charges will be stored. Okay, maximum limit of this one. So that extra charge, leakage of the charges can be reduced. Okay, so this is that is 10 to the power of 7. That is the voltage. Potential difference will be there in the let's see, here it is. Positive charges will accumulate, and how much it is? 10 to the power of 7. Okay, this is the 10 to the power of 7 is the maximum limit of the Van de Graaff generator. They told in the exam, they asked in the examination, what is the maximum value of the potential difference. Okay, that much you can store. That is 10 to the power of 7 volts. 10 to the power of 7 volts is the maximum limit. Okay. So, ಇನ್ನೇನು ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ ನೋಡೋಣ, ಇದೇ ತರ ನೋಡ್ತಾ ಹೋಗೋಣ. ಈಸಿಯಾಗಿ ಎಲ್ಲದೂ ಸಾಲ್ವ್ ಮಾಡಬಹುದು. ಅರವನ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಆಯ್ತಾ, ಸ್ಕೀಮ್ಯಾಟಿಕ್ ವ್ಯಾನ್ ಗ್ರಾಫ್ ಆಯ್ತು. ನೆಕ್ಸ್ಟ್ 3 ಮಾರ್ಕ್ಸ್ ಅಲ್ಲಿ list out the important results regarding the electrostatic of a conductor. So ಇದು 5 marks ಗೆ explain electrostatic potential at any point due to a short, very important. Expression for electrostatic potential at any point due to a short dipole. This is electrostatic potential ಮಾಡಿದ್ವಿ ನಾವು. Okay, point charge, electrostatic potential due to short, that we have to explain now. Okay. Consider, so then dipole AB, where is it? Dipole you can consider like this. Dipole means what? System of a dipole. Okay, system of 2 points. A is there, B is there here. Okay, it is at the center, it is O. Okay, it is one is maintained at plus Q and one is maintained at minus Q, and these two distances is what? This is L, this is L, this is 2L. Okay, very important thing. Okay, now it is consider ಸಿಂಪಲ್ ಇದು. ಓಕೆ, ಡಯಾಗ್ರಾಮ್ ಇಸ್ ಸಿಂಪಲ್, ಬಟ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಏನು 5 ಮಾರ್ಕ್ಸ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೇಕಲ್ವಾ ನಾವ್ ಇವಾಗ. ಕನ್ಸಿಡರ್ ಆನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಡೈಪೋಲ್ AB in which point charges plus Q and minus Q are separated by a distance 2L. Let P be a point on its axis separated by a distance r. Okay, illinda one point p ide. That a distance at a separated by distance r ide. Okay, r is the center of the dipole. Illinda illige distance is r. Okay, distance r from the dipole's center O. Electric dipole moment P is equal to electric dipole moment P is equal to Q into 2 times of L. Correct? Distance into charge. This is the one. Electric potential V of A Q2 plus Q of charge is how much? P of A is equal to 1 divided by 4 pi epsilon naught into Q divided by, where you have to calculate R minus 1 because it is at a R minus L. Same thing in the we electric potential R plus L ಆಗುತ್ತೆ ಯಾಕಂದ್ರೆ ಆಡ್ ಆಗುತ್ತಾನೆ. Therefore, total electric potential at P, this is a charge minus Q, okay, plus Q charge, it is minus Q charge at P. Total electric potential at P due to electric dipole will be V is equal to Q divided by 4 pi epsilon naught into D, correct? To L divided by Q is common, okay, 1 by R minus 1, this distance is how much? 2L, okay, 2L 1 minus R minus L plus 1 divided by R plus, yeah. So this is the answer. That is 2L is there. Where is that? So if you take this one, then what happens? It comes out to be Q into 4 pi epsilon naught into Q 1 by R and 2 times of L. Okay, R minus R square minus L square. A plus B into A minus B. Correct? So now L is less than R. So that what we can write V is equal to P divided by L is a short dipole. For short dipole, R is L is very, very less than R. Correct? Not L is a very small distance. So that what is that? For actual position, P is equal to Q divided by 4 pi epsilon naught into 1 by R square. No L. Okay, no for actual position. Formula is like this. You have to take this as a constant. Okay. Finally, you have to arrive at the potential. That is the potential at a ಶಾರ್ಟ್ ಡೈಪೋಲ್. ಶಾರ್ಟ್ ಯಾಕೆ ಮೆನ್ಷನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಎಲ್ ಇದೆಯಲ್ಲ, ಎಲ್ ವಿಲ್ ಬಿ ಇಲ್ಲ, ಶಾರ್ಟ್ ಇರಲಿಲ್ಲ ಅಂತಂದ್ರೆ ಇದೇ ಫಾರ್ಮುಲಾ ಬರೀಬೇಕು. ಇಫ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಶಾರ್ಟ್ ಮೀನ್ಸ್ ಯು ಹ್ಯಾವ್ ಟು ರಿಟರ್ನ್ ಅಟ್ ದಿಸ್ ಫಾರ್ಮುಲಾ, ಬಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಆಸ್ ಶಾರ್ಟ್ ಡೈಪೋಲ್ ಎಲ್ ಇಸ್ ವೆರಿ ವೆರಿ ಲೆಸ್ ದೆನ್ ಆರ್. ಆರ್ ಇಸ್ ತುಂಬಾ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಇನ್ ಕಂಪೇರ್ ಟು ಶಾರ್ಟ್ ಡೈಪೋಲ್ ಲೆಂತ್ ಆಫ್ ದ ಡೈಪೋಲ್. ಸೊ ದಟ್ ವಿಲ್ ಅರೈವ್ ಅಟ್ ದಿಸ್ ಈಕ್ವೇಶನ್. ಓಕೆನಾ? ನೆಕ್ಸ್ಟ್ ಇದು 2-3 ಕ್ವಶನ್ಸ್ ನ ಈ ಮತ್ತೆ ಮತ್ತೆ ಬ್ಯಾಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ 5 marks ಗೆ 3 marks ಗೆ ಖಂಡಿತ ಬಂದೇ ಬರುತ್ತೆ. ಓಕೆನಾ? ನೆಕ್ಸ್ಟ್ Van de Graaff generator is explain how Van de Graaff generator is charged. Okay, because of what? Because of the Van de Graaff generator ಎಲ್ಲದು ಮಾಡಾಯ್ತಲ್ಲ ಇವಾಗ. parallel combination of capacitors ಆಯ್ತು. ನೆಕ್ಸ್ಟ್ one is ಇದೆ. Capacitance of one plates are separated when find the ಇದು 2 marks ಆಯ್ತು. Electric field at the surface of a charged conductor of arbitrary shape. This is very important. Okay. Expression for electric field at the surface of a charged conductor. Electric field expression for electric field charged conductor. ಇದು ಮಾಡಿತ್ತಲ್ಲ ಅವಾಗಲೇ. Proportional to surface area. Correct or not? What is? The question is. Electric field at the surface of so it is arbitrary shape of a arbitrary shape. ಯಾವ್ದು ಬೇಕಾದ್ರೆ ತಗೋಬಹುದು. ಸರ್ಫೇಸ್ ಅಲ್ಲಿ ಹೇಗಿರುತ್ತೆ ಅಂತ. ಇನ್ಸೈಡ್ ಅಲ್ಲಿ ಯಾವಾಗ 0 ಇರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ನು. ಬಿಕಾಸ್ ಚಾರ್ಜ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಇಸ್ ವೇರ್ electric field on surface of any arbitrary. So here it is, we have to consider the Gauss law. Gauss law use ಮಾಡೋಣ ಅಂತೆ. ಇವಾಗ ಏನದು ಒಂದು ಆರ್ಬಿಟ್ರರಿ ಒಂದು ಶೇಪ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಯಾವ್ದೋ ಒಂದು ಶೇಪ್ ಅಲ್ಲಿ. ಓಕೆ, ಸೊ ಇಟ್ ಇಸ್ ಇಫ್ ಇಟ್ ಇಸ್ ಯು ಕನ್ಸಿಡರ್ ದ Gauss law. ಓಕೆ, from we know that from Gauss law calculate the electric field inside the arbitrary charge. Okay, this is a ಒಂದು ಶೇಪ್ ತಗೋಣ. ಈ ಶೇಪ್ ಅಲ್ಲಿ ಹೇಗೆ ಅಂತ ನೋಡೋಣ. From arbitrary shape, consider an arbitrary shape from Gauss law. Electric flux E is equal to sigma by epsilon naught. This is the one equation. Correct? Electric flux is this one, where sigma is what? Surface charge density. Electric charges ಇರುತ್ತೋ ಅದು surface charge density. Electric ಇರುತ್ತಲ್ಲ ಅದು surface charge density. So it is permittivity of free space free space. Okay. So this is a Gaussian surface. So you have from Gaussian surface, choose Gaussian surface on arbitrary shape of conductor. Okay. If it is there means we can write like this. And what is this total charge enclosed? That is up from Gauss law. Can write E into dA is equal to Q by epsilon naught. Correct or not? That is equal to where E into A is how much? E into A is nothing but how much? A into A is equal to sigma into epsilon naught. Sigma by epsilon naught into dA. Correct or not? E into dA. That is equal to into epsilon naught into A. Into epsilon naught into A. So epsilon get cancelled. So epsilon sigma into dA divided by epsilon naught into A. This dA cancels, okay? Dividing with what? A is equal to sigma divided by epsilon naught. So 3 marks question is. E is equal to sigma by epsilon naught iruttala adana derive ಮಾಡಬೇಕು of any surface charge distribution. Surface charge distribution na diagram ಇದನ್ನ ಬರೆದ್ಬಿಟ್ಟು ಯಾವ ತರ ಒಂದು diagram ತಗೊಂಡು ಹೀಗೆ we have to derive at this equation. Okay. ಈ ಟಾಪಿಕ್ ಅಲ್ಲಿ ಸುಮಾರು ಡೆರಿವೇಶನ್ಸ್ ಇದೆ, ಎಲ್ಲದನ್ನು ಸಹ ನಾವು ನೋಡ್ಕೊಳ್ಳೇಬೇಕು. ಆರ್ಬಿಟ್ರರಿ ಚಾರ್ಜ್ ಪೊಸಿಷನ್ ಕರೆಕ್ಟ್ ನಾಟ್, ಸೊ ದಟ್ ಇಸ್ ಪೊಟೆನ್ಶಿಯಲ್ ಎನರ್ಜಿ ಆಫ್ ಆರ್ಬಿಟ್ರರಿ ಚಾರ್ಜ್ ಇದೆ, ತುಂಬಾನೇ ಡೆರಿವೇಶನ್ಸ್ ಇರೋದನ್ನ potential due to a point charge, potential due to electrostatic potential due to a dipole that I calculated, right? Potential due to a dipole. Here is a potential due to a point charge. The last effect of dielectric of a capacitor ಕೇಳ್ತಾರದಲ್ಲಿ. So effect of dielectric of on capacitance ಅದೊಂದು ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ. Mention that is the effect of 5 marks ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ. Effect of dielectric on capacitance. Effect of dielectric on capacitance. So from the what is that effect of dielectric on capacitance ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ. That what is the formula? We know that electric field ಅಥವಾ ಕೇಳ್ತಾರೆ how the capacitance of a capacitor is altered ಅಥವಾ modified when dielectric is present. Dielectric ಅಂದ್ರೆ ಏನು? Air ಅಥವಾ ಇದನ್ನು insulator ಅಂತ ಹೇಳ್ತೀವಿ. Dielectric is present. Okay. If it is present, then what happens? Large plate tool, that is each of area. So ಈ ತರ ಏನಿದೆ, ಎರಡು parallel plate capacitors ಇರುತ್ತೆ. Okay. area A there. Both are having area A. And this on this, okay, they have the E as what? E as is equal to sigma by epsilon naught. So, idu electric field there. Okay, na? Next is, and B is equal to epsilon naught into A, D. Okay. Potential difference V naught is, potential difference V naught is equal to E into D. Correct or not? And C, capacitance C is equal to Q by V naught, that is equal to epsilon naught into A into D. This is the value we calculated, okay, in the parallel plate capacitor. But if the surface density is there, no, E is equal to sigma minus sigma of P divided by potential difference, E. If E is equal to what? E is equal to another different net surface. We have to calculate now net surface charge density. Charge density when dielectric medium, okay, dielectric, okay, is inserted between the plates. ಇದೆರಡು ಮಧ್ಯಕ್ಕೆ ಮಾಡೋ ಎಲೆಕ್ಟ್ರಿಕ್ಸ್ ಹಾಕ್ತಾಗ ಅವಾಗ ಏನಾಗುತ್ತೆ? So that is V is equal to, next line ಬರೀತೀನಿ ನೋಡಿ, V is equal to E into D, that is equal to sigma minus sigma of P divided by epsilon naught into D. We can write, okay, constant dielectric constants, okay, where epsilon divided by K, okay, that is a constant of dielectric constant. Dielectric constant, okay, that is equal to sigma minus sigma of P is equal to sigma by K, that is dielectric constant. So B is equal to sigma of D divided by epsilon naught into K. K substitute mana is equal to Q into D divided by A into epsilon naught into K. And C is equal to what? C is equal to epsilon. If we get capacitance of a capacitor, but epsilon naught into K into A divided by D. Okay. So product is known as K epsilon, the permittivity of the medium is denoted by epsilon. Okay. Epsilon naught into yes, epsilon naught at K is equal to, instead of writing this one, we can write epsilon naught into K. Epsilon naught into K is known as the permittivity of medium. Because constant introduce madrinda. So that is what? That is epsilon naught into K. K is equal to, you can write epsilon naught is equal to epsilon naught into K. Permittivity of the medium. Epsilon naught is permittivity of the medium. Epsilon naught is what? Medium. Idu permittivity of free space, vacuum. Okay. ಹಂಗಾಗಿ ಮಲ್ಟಿಪ್ಲೈ ಆಗುತ್ತೆ, ಕಾನ್ಸ್ಟೆಂಟ್ ಒಂದು K ಮಲ್ಟಿಪ್ಲೈ ಆಗುತ್ತೆ. therefore K is equal to space ಅಥವಾ air. K is equal to epsilon divided by epsilon naught is called dielectric constant of the substance. Dielectric constant of the substance. ಇದನ್ನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡಿದಾಗ ಏನಾಯ್ತು? epsilon is epsilon into K. K is equal to C by C naught. It is what? In the medium and it is in the air. Okay. A dielectric constant of a substance so any type of capacitor. Okay. Dielectric constant of a substance is a factor by which capacitance increases. Relative constant is a substance of a factor by which capacitance increases from its vacuum value. Plates of any shape of capacitor. ಇದು ಪ್ಯಾರಲ್ ಪ್ಲೇಟ್ ಅಂತಿಲ್ಲ, ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ ಪ್ಯಾರಲ್ ಪ್ಲೇಟ್ ಇಂದ, ಬಟ್ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಏನಾಗುತ್ತೆ, ಇಟ್ಸ್ ಅಪ್ಲಿಕೇಬಲ್ ಫಾರ್ ಎನಿ ಶೇಪ್ ಆಫ್ ದ ಕೆಪಾಸಿಟರ್. ಓಕೆ, ಕೆಪಾಸಿಟರ್ ಓಕೆ ಪ್ಯಾರಲ್ ಪ್ಲೇಟ್ ಇರ್ಬೇಕಂತ ಏನಿಲ್ಲ, ಸಿಲಿಂಡ್ರಿಕಲ್ ಕೆಪಾಸಿಟರ್ಸ್ ಅಲ್ಲೂ ವರ್ಕ್ ಆಗುತ್ತೆ. ಸೊ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ಕೆಪಾಸಿಟರ್ಸ್ ಇರುತ್ತೆ. ಇದು ಎಲ್ಲದನ್ನು ನಾವು ಏನ್ ಮಾಡಿದೀವಿ, ಸೊ 3 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ 5 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸ್ ಅಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ ಆಲ್ ಎಲ್ಲ ಡೆರಿವೇಶನ್ಸ್ ನಾನು ಕವರ್ ಮಾಡಕ್ ನೋಡಿದೀನಿ. ಈಗ ಅಷ್ಟನ್ನು ಸಹ ನೀವು ನೋಡ್ಕೊಳ್ಳಿ. ಸೊ ದಟ್ ಇದು ಯಾವ್ದಾದ್ರು ಎಲ್ಲಾದ್ರೂ ಸಹ 3 ಮಾರ್ಕ್ಸ್ ಮತ್ತೆ 5 ಮಾರ್ಕ್ಸ್ ಅಲ್ಲಿ ಯಾವ್ದಾದ್ರು 1 3 ಮಾರ್ಕ್ಸ್ 1 5 ಮಾರ್ಕ್ಸ್ ಬರುತ್ತೆ. ಸೊ ದಟ್ ಈಸಿಯಾಗಿ ನೀವು ಸ್ಕೋರ್ ಮಾಡ್ಬೋದು. ಇಷ್ಟನ್ನು ಸಹ ನೋಡ್ಕೊಂಡು ಕರೆಕ್ಟ್ ಆಗಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋಗಿ ಆನ್ಸರ್ ಬರುತ್ತೆ. ಓಕೆ, ಸೊ ಎಲ್ಲದನ್ನು ಸಹ ಸ್ಟೆಪ್ ಬೈ ಸ್ಟೆಪ್ ಫಾಲೋ ಮಾಡ್ತಾ ಹೋಗಿ. ಸೊ ಯು ವಿಲ್ ಗೆಟ್ ದ ರಿಸಲ್ಟ್. ಓಕೆ, ಸೊ ಏನು ಇಲ್ಲಿಗೆ ಏನಾಯ್ತು, ಕೆಪಾಸಿಟೆನ್ಸ್ ಪೊಟೆನ್ಶಿಯಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಶಿಯಲ್ ಕೆಪಾಸಿಟೆನ್ಸ್ ಚಾಪ್ಟರ್ ಇತ್ತಲ್ಲ, ಅದ್ರಲ್ಲಿ ಏನೇನ್ ಬರ್ತಿತ್ತು, 1 ಮಾರ್ಕ್ ಅಥವಾ MCQ ಬರ್ತಿತ್ತು, 2 ಮಾರ್ಕ್ಸ್ ಬರ್ತಿತ್ತು, 3 ಮಾರ್ಕ್ಸ್ ಬರ್ತಿತ್ತು, 5 ಮಾರ್ಕ್ಸ್ ಬರ್ತಿತ್ತು. 2 ಮಾರ್ಕ್ಸ್ ಇಂದ ನ್ಯೂಮರಿಕಲ್ಸ್ ಬರ್ತಿತ್ತು. 3 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸ್ ಓಕೆ ಡೆರಿವೇಶನ್ಸ್ ಅಂಡ್ 5 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸ್ ಆಲ್ಸೋ ಡೆರಿವೇಶನ್ಸ್ ಆಲ್ಸೋ. ಎಲ್ಲದನ್ನು ಸಹ ನಾನು ಡೆರಿವೇಶನ್ಸ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ ಎಲ್ಲದನ್ನು ನೋಡ್ಕೊಳ್ಳಿ. ವ್ಯಾಂಡಿಗ್ರಾಫ್ ಜನರೇಟರ್ ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಇದೆ, ಅದನ್ನು ಸಹ ನೋಡ್ಕೊಳ್ಳಿ. ಎಲ್ಲದನ್ನು ಸಹ ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಈಸಿಯಾಗಿ ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಆರಾಮಾಗಿ ಮಾರ್ಕ್ಸ್ ಸ್ಕೋರ್ ಮಾಡ್ಬೋದು. ನೆಕ್ಸ್ಟ್ ಚಾಪ್ಟರ್ ಜೊತೆ ಬರ್ತೀನಿ. ನಮಸ್ಕಾರ.